All right, we're going to go on to our next section, which is arithmetic series. Now, the first thing I want to mention is that series in general are not technically an 8th grade topic, so you won't see anything about series on the MCAs. But they do go over a series in your AOPS book, and I found that in AOPS they go into series really fast and really deep, and so students kind of struggled with it because it was so deep so fast. So I wanted to do a very quick overview of series so that you get some easy problems under your belt, so that when you do see them later on in AOPS, which is in chapter 21, that they'll be a little bit more familiar to you. So just a quick reminder, take a moment, pause the video in a minute, and look on page 594, and just give yourself a basic reminder, what's the difference between a sequence and a series? So pause the video, answer the question. All right, so just a reminder, a sequence, what we just did in the previous section, is just a list of numbers. And in this particular case, we're talking about arithmetic sequences, so it's a list of numbers that are being added or subtracted by the same amount each time. And a series is the sum of all of the terms, in a sequence. So we're taking all of those terms and we're adding them up. So in the AOPS book on page 596 to 97, Problem 21.6 shows you how these formulas come to be. It's really interesting. I want you to take a look at it. But for now, I'm just going to show you what the formulas are and how the formulas, like how you use the formulas. All three of these formulas are the same formula. We're just writing them in a slightly different way. I particularly like this third one because I think it's really easy. So an arithmetic series has a sum. That means we're adding up all of the terms, and that sum is the number of terms in the sequence multiplied by the average of your first and last term. And that's really easy. Number of terms times the average. This formula up here is the same formula, just rewritten. So this number of terms, and how do we find average? We take your first term plus your last term and divide it by 2. So number of terms times your average. This fancy funky guy here is just another way of saying number of terms times the average. And I'll rewrite this a little bit so you can see. So here's your number of terms times, okay, well, how do we figure out the average? Well, my first term is going to be A. That's my first term. And how do I write my last term? Well, from last section, we saw that we can write it as A, my first term, plus my common difference, times n minus 1. So this right here is my last term. And I'm going to be adding these together. So first term plus my last term, and average means dividing by 2. So when we simplify this whole funky thing, we get A plus A is 2A. Plus n minus 1 times d, or d times n minus 1, divided by 2 to find the average times your number of terms. So all three of these things are saying the exact same thing. Number of terms times your average is going to give you the sum of all of the terms in your sequence. Let's go ahead and do some practice problems, and you're going to see that these formulas are really easy to work with. So problem number 1, evaluate, which just means just find the sum of each arithmetic series based on the following information. A to the 1 is your first term. It's not A to the 1, but A1. Your last term is A to A sub n, or however we say that. And n is your number of terms in the sequence. Okay, so I'm just going to use my formula. Number of terms times my average. And I'm going to plug in what I know. Number of terms, there are 13 terms. My average, well, is my first term plus my last term divided by 2 because there are 2 terms, first plus last. And I'm going to use my handy dandy calculator. I love my calculator. And I'm going to figure out my average first. 74 plus 386 is 460 divided by 2. So my average is 230. I'm going to multiply that by the 13 terms, and I get 2,990. So that is the sum of all of the terms in this sequence. Now, I'm going to take a moment. You don't have to do much with this, but I did want to kind of say, what does this mean? Like, it's important that we know how to use the formula, but it's also important that we know what in the world is the formula doing. So here's just kind of a quick what this sequence looks like for number 1. I know that my first term is 74. I know there are 13 terms in here, so there's 13 spaces for terms. And I know my last term is 386. And I know I have to add each of these terms to get up to 2,990. But what in the world are these terms? I mean, our last section, we wanted to know our common difference. I don't know the common difference. I don't know the second term. What's going on here? Well, what we could do, just to kind of give you an idea of what this is, like how this looks, is I know that my difference between my first and my last, my total difference is going to be, so total difference is going to be 386 minus 74. So that's how much my sequence is changing from the beginning to the end. And that is 312. So there's 312 steps, so to call, in between these. And that is shared equally between how many terms? There's 13 terms. So my common difference is 24. So 74 plus 24 gives me my first one, or actually my second term. That would be 98. So adding 24. And then I'm going to add another 24. That's going to give me my third term. Adding another 24 gives me my fourth term. So on and so forth. That's going to give me all of my terms. Then, after I would do that, I would just add them up. 74 plus 98 plus 122 plus 146 plus 386 gives me 2,990. So I could do all of this funky work, find all of the terms in my sequence, add it all up to get my answer. Or I can use my wonderful formula and go, well, if I know that the average of all of my terms is going to be, what was it? I forget what it was. 74 plus 386 divided by 2. My average is 230. So that was my average. That's kind of like saying each term really is 230, and I have 13 of them. So my average is so my total is 2,990. So that's how the formula works, and you can go back in your AOPS problem, page 596, to learn more about that. But that's why the formula works and what we're really doing in these problems. Let's go back and just use our handy dandy simple formula. Yay! So let's find, in this problem, again, number of terms times your average. Okay, my number of terms is 8. My average, in this case, is my first term is negative 46. My last term is negative 683, so I know that I'm decreasing in my sequence. I'm going to divide that by 2. And then I'm just plugging this in my calculator. Negative 46 minus 683 divided by 2. My average is negative 364.5, and I have 8 terms. So that is negative 2,916. So that is the sum of that sequence. Let's keep on going. I would recommend going ahead and trying to solve number 3 and 4, and then so pause the video and then see if you get the right answer. Here we have some quick problems on how do we find the sum of a sequence, which is a series. And those are some nice easy problems. Let's go ahead and turn the page, and we'll do Some a little more challenging ones. Oh my goodness, there's words in there. All right, with any word problem, I like to identify what I know in it. Let's see, the first term and the last term of an arithmetic series is square root of 3 and 300 square root of 3 respectively. And that just means that that goes in the same order. So the first term is square root of 3 and the last term is that. So I'm going to go ahead and write that down. So first term is square root of 3 and last term, I'll write a to the n, is 300 square root of 3. The sum of the terms is this. So this actually gives us the sum. So 3,612 times the square root of 3. I want to find the number of terms. Well, again, I'm going to write down what I know. I know that the sum, I'll write S or sum, equals the number of terms times the average of my first and last term. So I'm going to plug in what I know. The sum is 3,612 square root of 3. And that equals the number of terms, which I don't know, so I'm going to call it n, times my average, so that is square root of 3, plus 300 square root of 3 divided by 2. Okay, now I just want to solve for n. Let's see, I'm going to multiply, well, first I'll go ahead and simplify this, and then I'll multiply by 2. So 3,612 square root of 3 equals n times 300 plus there's an invisible 1 here, so that's technically 301 square root of 3 over 2. I'm going to multiply everything. Actually, I could just multiply it by the reciprocal. Just do it in one move here. Okay, so I'm going to multiply this by the reciprocal. So this all cancels out. And I'm going to multiply it by the reciprocal over here. 301 square root of 3. Okay, over 1. And what happens here? My square root of 3's cancel out. Yay! And I have 3,612 times 2 over 301. Well, let me just find out what that is. 3,612 times 2. Let's see if it comes out nicely. Divided by 301. It should come out nicely because we're looking for a number of terms, and that should be an integer. You're not going to have 4.5 terms. Ooh, 24. Nice. So there are 24 terms in that sequence. And all of the terms add up to that really fun number right there. All right, I would recommend try numbers 6, 7, and 8. And then try number 6 and then check your answer. Try number 7, check your answer. Try number 8, check your answer. I'll go ahead and solve the problem just in case you're still kind of needing some extra help with that. Fiona was gifted a piggy bank for her birthday. Lucky her. She saves up $15 from her allowance in April, 23 in May, 31 in June, and so on. How much will her piggy bank contain at the end of 12 months? Well, first of all, I look at this. Is this an arithmetic sequence? I go from 15 to 23, which is 8, 23 up to 31, which is 8. So basically my common difference, she's adding $8 each month. Her first one that she starts with is $15. And how much at the end of 12 months? So N is 12. And how much will her bank contain at the end? Because she has an empty piggy bank. She puts $15 into it in April. She puts $23 into it in May. Oh no, she starts with $15. Oh yeah, in April, 23 in May, 31 goes in June, and then more goes in July, and so she keeps doing that. At the end of 12 months, how much will her piggy bank contain? That's an arithmetic series. So we're gonna go ahead, in order to do an arithmetic series, the sum is the number of terms, which I know, times my average, and my average is my first and my last term. I know my first term, I do not know my last term. So I need to figure out my last term before I can use my beautiful formula over here. So that comes, that was our last section. So to figure out my last term, let's see. My formula was this, the nth term is my first term plus my common difference times n minus 1. That was our formula that we used in our last section. So my last term is going to be my 12th term. It's my first term. My common difference is 8 and 12 minus 1. And when I go ahead and do the math there, 8 times 11 plus 15 is 103. So on the 12th month, she's going to be adding in $103 into her piggy bank. Now I can go ahead and find the sum of all of those months. So my sum is my number of terms, 12, times my average, my first month, plus my last month, divided by 2. So I can just use my handy dandy calculator, 15 plus 103, divided by 2. The average is $59 a month, and there are 12 months. So her piggy bank has a whopping $708 in it after 12 months. Go Fiona. All right, let's go ahead and do number 9. Grog, maybe you'll recognize these names from our Beast Academy from several years ago. Grog stacks 7 rows of firewood on old pallets. And again, I'd recommend pausing this, seeing if you get it, and then check in with us. 7 rows of firewood on old pallets to make provision for winter. The bottom row contains 18 logs, and the top contains 6 logs. So if I were to draw a picture, like here's my bottom row with 18 logs, and I have, I don't know how many rows I have, but how many rows he ends with? Oh, there's 7 rows. So 1, 2, 3, 4, 5, 6, 7, kind of like a pyramid. The top row has 6 logs. If the logs are arranged in an arithmetic progression from bottom to top, how many logs of wood can be found in the total pile? That tells me that this is a series because I'm trying to find the total. Well, let's see, my first would be 18. My last term would be 6, and I know that there's 7 piles. I've got everything I need to know right here. My sum is my number of terms times my average. Number of terms is 7. My average is 18 plus 6 divided by 2. 18 plus 6 divided by 2 is 12 times 7, 84. So he has a total of 84 logs on that pile. So hopefully at this point you're finding that you can use the formulas for a series pretty easily. This next one, this next 2 problems are definitely a challenge. So if you don't get these right away, that's totally fine. But we're going to be a lot of space here. We're going to be using up a lot of space. So let's go over these examples. Let's be prepared to use some things that we learned last year. All right, for number 10, or for challenge, find the number of terms in each finite arithmetic series, meaning they finite, they're only going to have a certain number of terms. They're not going on forever. Our hint is use the formula and plug in what you know how to find n. There's going to be a lot of steps. Okay, so let's kind of figure out what this is. I have -12, -8, there should be commas in between here, -4, and I'm going up to n terms, and my total is 2,222. At first that might not make sense because I have negatives here, but I'm increasing by 4, so I know that the rest of my terms are going to be positive up to a certain number of terms. So, well, let's say, what do I know? It's always good just to write down, what do I know? And I do know that in order to find my sum, I need to know my number of terms, which I don't know, times my average of my first and last term, and I don't know my last term. So I need to know what my last term is. So I go back to my last section. Last term, well, any term can be written as the first term plus the common difference times n minus 1. So my last term, which I'm still writing as a to the n because I don't know how many terms there are, is my first term plus my common difference times n minus 1. Okay, so this is my last term. Whew. Well, let's just start plugging stuff in, and I might get something really funky. So my sum is 2,220. N, do not know. But I can kind of write what my average is. So my average is, I'm going to do this, is my first term plus my last term, which is this, -12 plus 4 times n minus 1, all divided by 2. So this is my average, and this is my number of terms. Ooh, so I have n, I only have one variable, so I can solve this, but it might look a little funky. Let's just go ahead and use our rules for algebra and see if we can start simplifying this. So 2,220 equals n. I'm going to simplify what's in here first. -12 plus -12, that's going to be -24. I'm going to distribute 4n minus 4 all over 2, n times, that is -12, -12 is -24, -4 is -28, plus 4n over 2. I'm going to go ahead and divide each term by 2. That's -14 plus 2n. And I'm going to go ahead and just continue that 2,220. And I'm going to distribute my n. Ooh, -14n plus 2n squared. Holy moly! You might notice we've got a quadratic because I have an n squared. Can we solve this? Yes, we can. I'm going to move everything over to one side so I can use my quadratic formula. So I'm going to subtract 2,220 to get 0 equals. I'm going to put my quadratic term first, my linear term second, and then my constant term last. So I just rewrote this equation as this one because now I can use, my favorite, quadratic formula. We'll be doing a lot of quadratic formula. So if you don't remember what the quadratic formula is, here it is. To our favorite song, Pop Goes the Weasel, x equals -b plus or minus a square root b squared minus 4ac all over 2a. All right, here's my a, here's my b, and this is my c for constant. Let's plug in what we know. I told you there'd be a lot of steps. x equals negative b, so the opposite of negative 14 is positive 14, plus or minus the square root of b squared, negative 14 squared is the same as 14 squared, minus 4ac, make sure we're keeping those negatives, all over 2 times a. Whoo, super fun. 14 plus or minus the square root of, okay, 14, oops, let's turn you on. Yeah, 14 squared, where's my, I don't have a square button on this one. That's annoying. To the second. That's 196 minus 4 times 2 times 2, 2, 2, 0. It's 17,760, and I know that this is going to be a positive because I have 2 negative signs, so that's going to end up being a positive. All right, 196 plus 77760. That equals 14 plus or minus the square root of 17,956. Super fun. Square root of that, 17,956. And I'm looking back, I'm trying to find n, which is number of terms. So I know I'm going to end up with an integer because number of terms has to be a whole number. So this should simplify nicely. If it doesn't, then I did something wrong. It does. 14 plus or minus, oops, 134. Oh, and this is all over 2. Oh, actually all over 2a, which is 4. Don't forget about that. Okay, so I have 2 options here. I have 14 plus 134 over 4. 14 plus 134 divided by 4. That is 37. And I have 14 minus 134 over 4. 14 minus 134 divided by 4. That is negative 30. In this particular case, there's only one answer. I can't have negative 30 terms. So this is my answer, 37 terms. So n equals 37 terms. Whoo! That was a lot of work, but again, it's much easier if you just go, okay, what do I know? How can I start? Do I need to figure out anything? And then here, this was all things that we actually have done before. So we just have to be careful that we, do them right. But yeah, that was definitely a challenging problem. If you want to try number 10 on your own, it's going to be the same kind of thing. Start with what you know, try to figure it out, pause the video, and we'll see if you get the right answer.